Hello, so we will talk about chapter 8 right now. And so let me check. So let me share my screen with you and then we can start from here. So chapter 8's title is data wrangling, join, combine, and reshape. So I think, okay, the first part we will look at is hierarchical indexing. So sometimes there will be like the index, which is we have multiple index levels. So it provides a way for us to work with high dimensional data in a lower dimensional form. So I have the first question here is that why we need this kind of multiple indexing? Why do we need to use it? It seems so complicated, right? Why we just use it as just one index and the other one can be a column? Yeah, so that's the question for you. And so when we are seeing, what we are seeing is a prettified view of a series. Yeah, what do we see here? Okay. This is the index. What we see here is a prettified view of a series with a multi-index as the index. So the gaps in the index display mean use the label directly above. And with this indexed object, so the partial indexing is possible. We can select subsets of the data concisely. So how to understand this right now, we have this data frame, right? And then data B. So what is data B? Okay, two of them, the number two of them. And what I want is B2C. Okay, B2C. So these are the values. And what we want is, okay, B and D, just B and D. So that's how we get those rows. So we can also select from inner level like this. So the second one of ACD. Okay, this one, right? This one and this one. So we can select the data from the outer index and the inner index here. And we can also use unstack to rearrange the data into a data frame. So it is, if you think it's very complicated, you can use this way to actually decompose the original data frame. And the inverse operation of unstack is stack. So what we can do is unstack stack, then we will return to the original one. And here is also another multi-index. So let's check the multi-index frame dot index, and you can see this is multiple index, and we want to change index. So we the hierarchical levels can have names. So this will show up in the console output. We can assign index names here, and then we assign column names. So see, the original one is like this, and right now we have, okay, state, color, and key 1 and key 2. So with partial column indexing, we can select groups of columns. So frame Ohio, green color, green, red. Okay, so that's what we can get. At the same time, a multiple index can be created by itself and then reused. A column in the preceding data frame with the level names can be created like this. So there is no multi-index. That is because, yeah, if we add pandas and then we can get the result we want. So the next part is reordering and sorting levels. So the swap level takes two level numbers or names and it returns a new object with the levels interchanged. So we can swap we can swap the index, the order of index, and use sort index sorts the data using only the values in a single level. When swapping levels, it's not uncommon to also use sort index so that the result is sorted by the indicated level. So let's see what happened here. Okay, I use sort index, level is 1. So I sort by key 1 and then I swap level. So after swap level, then I sort level 0. So the level 0 right now is key K2, key 2, okay? Okay, so the next part we are looking at is summary statistics. By level, we can add the key numbers, key 1, we can add, okay, it's here. Okay, we can add the key numbers together. It seems like group by actually. So yeah, 1, 2. See 1, 2, and 6, 8, 10, right? 6, 8, 10. And when the level is color, what will be the result? So the color, if it is color, then we can see we have green, red, green. And right now we only have green, red. So green is 2, 14, 8, 20, 2, 820, okay, 4820, and so that's how we use this sum to do the summary statistics at level. Then we will look at indexing with the data frames columns. So we have this data frame, okay, we have 4 columns and 7 rows, and so we want to set index to 2 column, and this is the result. And after that, we set index, frame set index C and D, and job. So job is equal to false. It means the columns are removed from the data frame, though we can leave them in. So it's like this. Okay, we want to leave those 2 columns still here, and the frame 2 reset index. So here is frame 2 that we set the new index here, and if we reset index, we can see that, okay, it does the opposite of set index, right? So the next part we are looking at is combining and merge data sets. So for me, I always use join. So we can use left join, right join, inner join, and sometimes maybe cross join. And so join is, and also I know some people will use merge and also like append. So let's check in this chapter what like method it used. So I can see there are concat, there are join, there are merge. and I are like combine first. So yeah, let's check this part carefully. So we have two data frame here. One is data df1, df2, and the only thing that is are the same is the same. Only column is key. So what we will do is merge. So merge df1 and df2 together, and so the merge actually gets the result. We don't need to specify which column to join on. If that information is not specified, the merge uses the overlapping column names as the keys. So here is how we assign which column we should join on, we should merge on. So if the column names are different in each object, we can specify them separately. So in this way, merge left on, right on, and we can see that. So for merge, we return everything. We return just 6 rows, but we have 7 rows here, and we have 3 rows here, right? So when we do merge df1, df2, then we have, okay. So C, we have B, key is B. So for C, right, because for C, there are, in df1, there is a key name is C, but there is no, not any, like the key is C in df2. So there are only, actually, for 6 rows left. So this is how they do merge, and so it is actually an inner join because I cannot see we return everything in df1 or just return everything in df2. So this is an inner join, and so we can see, we can prove that here, which is, okay, we have df3, df4, and so when we add, when we merge them together, one use L key, K key, one use R key, and ABD. So this has ABD, this has ABC. So we only have, so the result we can guess there are only 6. I still think there are only 6 of them. Let's check. 6 rows. Yeah, I'm correct. So the next part we will look at is that, so by default, merge does an inner join the keys in a result, intersection, or the common set found in both tables. So yeah, I'm right. And the other possible options are left, right, and outer. So the outer join takes the union of the keys, combine the effect of apply in both left and right joins. So that's how we use inner, left, and outer. Inner use only the key combinations observed in both tablets. Left use all key combinations found in the left table. And the right use all key combinations found in the right table. And the outer use all key combinations observed in both tables together. So this is a very common question, or when you are interviewed, I mean, if there are in the job like description, and they ask you that you need to have the skills of SQL. And so when there are any questions that are related to SQL, so this question is, I should say, is 99% that you will be asked. So they will ask you, what is join, and what is the difference of left join and inner join? Explain that to me. So I hope we can prepare well for these basic questions. Yes. So this is a way to tell us to to differentiate inner join, left join. And another way, the last part is that, when we have multiple keys, we can pass a list of column names. So in this way, we can know, okay, which which column come from which data frame. So the merge function arguments, there are lots of them, like left, right, how on, left on, right on, left index, right index, sort, suffixes, copy, indicator. So I mean, we need to know more about this part so we can do a perfect join and to prepare our data well. And then merge on index, that is the next part, which is okay. So in some cases, the merge in data frame will be found in its index. In this case, we can pass left index is equal to true or right index is equal to true to indicate that the index should be used as merge key. So how can we do this? Here is an example. Okay, we have two data frame here, right? And what is the left one? Okay, it looks like this. So what is right one? It looks like this, and we want to merge. We want to merge. So left on key and right index. Okay. Right index is equal to true. So see, that's the result. And so with this index, with multi-index data, things are more complicated because as join on index is a multi-key merge. Okay, let's see what that looks like. Okay. So we can see for the second data frame, the right, we have multi-index. So we want to join together. On right is key 1 and key 2. For on left is key 1 and key 2. On right is the index. Okay, so that's how we do it. And the next part we want to look at is using the indexes of both sides of the merge is also possible. So these two must have, both has multiple index, right? And how can we join them together? Left index, right index is equal to true. So we will join it like this. And there is another way to just use join. So this is right 2, and so just to use join, join actually merge by index. So it also can be used to combine together many data frame objects having the same or similar indexes but non-overlapping columns. So join is an easy way to do the merge because it just merge by index. And in part for some legacy reasons, the frames join method performs a left join on the join keys exactly preserving the left frame's row index. So it also supports join the index of the past data frame on one of the columns of the calling data frame. So we can see that for join, we always use left join. And then for simple index on index merge, we can pass a list of data frame to join as an alternative to use the more general cancate function described in the next section. So let's check what's the meaning of this one. Okay. So this is a meaning another. Okay, what's another looks like? Okay, it looks like this. And right now I have another, so I want to join two. Okay, two data frame to the left too. So what happened here? Okay, it looks like this. And okay, we want outer join. So this is crazy. I have never used it before. I mean, to join two data frame to another data frame. So, okay, I have learned. And then let's go to next part, which is concatenating along an axis. So, this function can do this concatenate function can do like banding stacking with the NumPy arrays. So right now we have this array, right? Have this array here, and let me print this array and to see what's in there. So yeah, this is the array, and what we do is to okay, I just combine. Seems I combine them together. So in the context of pandas, objects such as series and data frame have been labeled access enable us to further generalized array concatenation. In particular, we have a number of additional things to think about. First, if the objects are indexed differently on the other axes, should we combine the distinct elements in these axes or use only the shared values? Second, do the concatenated chunks of data need to be identifiable in the resulting object? Third, does the concatenation access, okay, I cannot pronounce this word, and contain data that needs to be preserved. In many cases, the default integer labels in a data frame are best discarded during the merge. So this function in pandas provides a consistent way to address each of these concerns. So we have some examples to illustrate how this works. For example, we have S1, S2, S3 series. Okay, look like this, and then we do concate A, B, D, E. Okay, which there should be A, B, D, E, G, right? So why it be filled something, right? It looks so weird. Oh, A, B, C, D, E. Okay, here is C, sorry. A, B, C, D, E, F, G. Okay, I don't have a problem here. So by default, Kankit works along axis 0, producing another series. If we pass axis is equal to 1, the result will instead to be a data frame. So how to understand this? Okay, access is equal to 1. So we have a data frame here. This is index, this is the number, and okay, so for C, yeah, the number is 2. And that's from S2. Okay, I understand it. So in this case, there is no overlap on the other axis, which as we can see that is the sorted union of indexes. We can instead intersect them by passing join inner. For example, for S4, let's see the result, PD cancade. This is the result, right? But if we use S, what we will have is, okay, right now we have a data frame, and if we do join inner, then this is the result. We only have the things that are the same. So for S1 and S4, okay, S1 is this, S4 is this, and the only same thing is AB01, right? Okay, so that's what we can use for Kankit. And in also what we can look at here, which is we join the access. So we can specify the access to be used on the other access with the join access. So S1 and S4 access is equal to 1, and join access is equal to ACBD. So it is said that it cannot, PD cannot got an unexpected keyword argument join access. So we cannot use it anymore, I think. Let's check, because I have a new version of Python, so we cannot use that anymore. And I think we have other ways to achieve this goal. It's not join access. See, I actually cannot find the join access here. So let me check. Okay. Join access. Okay. So we don't have like this anymore, but okay, so join access. Can we use keys here? Let me try it. Can we use keys instead of join access? Keys. Okay, so let me remove this bracket. So here is the result. We have, and this is not what we want actually. Because we want to specify the access to be used on the other access. So that number should be like index. Should be index. So, okay, let me check if index can work. No, so still I cannot work with index, which is confused for me. So how to do it? Okay, maybe we cannot do it this time. We can, let's go to next, and I will leave here as an example how to do it in another way. So a potential issue is that the concatenated pieces are not identifiable in the result. So suppose we want to create a multi-index on the concatenation access. So to do this, we will use the keys argument. Then we do on stack. So let's see what's the thing after the result. And then what we have is unstack. So in this way, we know where the data comes from. And in the case of combining series, a long access is equal to 1, the keys become the data frame column headers. So let's check. Okay. So in the next thing we can look at is the same logic extends to data frame objects. So right now we have 2 data frame here, right? One is df1, one is df2. Okay, so I have 2 column, 3 rows, 2 column, 2 rows, and I concatenate them together. So I have 1, 2, 3, 4, and A, B, C. So I can separate which data come from which data frame, right? And also I can use in this way, which is, okay, level 1 means the data frame 1. And what I can do else is that we have like, we have a name for each level. So one is upper level and one is lower level. This is, we can like manage how the multi-index is created. And the next thing is data frame. So the row index does not contain any relevant data, right? But what we can do is we can use concate to achieve this goal, to know which row come from where. So right now we have A, B, C, D, and we have, okay, we have 3 and 4. So we don't have 3 and 4 here. See? But what we have is, okay, 3 and 4. So actually these are the values of df2, right? So then we know the row index contain the relevant data. So that is the part of concate. Let's go to the next part, which is combining data with overlap. So there is another data combination situation that cannot be expressed as either a merge or concatenation operation. We may have 2 data sets whose indexes overlap in full or part. So we will consider the NumPy where function. How to do this? Let's check our data frame first. Okay, it looks like this is more, it looks like, okay, it has names for each level, and then we stack it and unstack it, and we unstack based on the state. Okay, sorry, I think I want to talk about this part but I'm looking at this part. So let's go back to this part, combining data with overlap. So right now we have A and B. So what is A? Okay, what is B? They are two series. So this is A and B. They have the same index but different values. So right now, for B, I want to sign a value to be an A, and so what I want to do is np.where PD is now in an A, is now in A, this three, right? F, D, and A, they are now values. And then on these values, I will fill it with B's value. So this will be 0, D will be 2, A will be still none. Let's check the result. So we can see, okay, 0 and 2 and now and then. So that's what we do with this where. Series has also a combine first method which performs the equivalent of the operation along with the pandas usual data alignment logic. So in this way, combine first with A's number, every value after 2. So let's check what's in A2, what's in B2. Okay, this is B, and this is A. So we have FEDC, and let's check the result. So what we will combine first. So here for A, okay, A is now, for B is 4.5, and for C, we will use the first one is 3. For D, we will use 2, E is 1, and F is 0. Okay, so that's what we will do. And so that's all how we use. Okay, let us check the last example here, which is DF1, DF2. And then what we will do is combine them together. Use the combine first. So df1 dot combine first df2. What will happen? So we have, okay, like this, and A, B, C, D here, and so actually every number is in df1 because df1 is bigger than df2, right? But what if we use this? Okay, I have df2 and I combine first df1. So we can see some difference. For example, for A, right? For A, this is from df2, and this is from df2. So that's all about chapter 8, indexing and also join. And the last part of this chapter is reshape and pivoting. So I will leave this part later to finish this part later. That's all for this video. Thank you for watching.